have more practice. So again, all of this is just practice with different types of factoring. So we are going to continue on until all the practicing is done. So again, I've got 4 terms. The first thing I do every time I factor is see if there's something common. So they've got 6's, they've got x's, they've got c's, they got 1. But there's nothing common across all 4 terms. So I'm going to try factoring by grouping. So I'm going to look at this first chunk, and I notice that I can divide out a 6. So that's going to leave me with an x squared plus 1. Because remember, you're dividing. And then when I divide out what's common here, well, remember, I want to lead off positive. So I know whatever I pull out is going to be negative. And I'm going to divide out a c, and that's going to leave me with an x squared plus 1. So now, tell me what is in parentheses, which is what is common among both of these terms. So if we go back through and look at that chunk and this chunk, each of these red chunks has an x squared plus 1. And then what's left, once I pull that out, is a 6 minus c. Let's try another one. All right, so I've got an a squared plus a 3a. And then plus a 6aq, and plus an 18q. So the first thing I want to do anytime I factor is see if there's something common. So I look, he's got a squareds, there's no other a squareds. Okay, he's got a's and he's got a's, but not across all 4 terms. He's got a q, but there's no other q's. I can pull out a 3 from here, here, and here, but there's nothing I can pull out from all 4 terms. Okay, so I am going to look at the first 2. What's common on just the first 2 is I can divide out a. And when I divide both terms by a, I'll be left with a plus 3. What's common on the last 2? Well, I can pull out a 6, and I can pull out, well, that's about it. So I'm going to pull out a 6, and then I forgot my q. That's why I'm stumbling. Sorry. Good heavens to Betsy. I was like, this is not factorable. All right, so this one had a q on it that I forgot to write down. So I can pull out a 6q. And when I divide the first term by 6q, I get an a. When I divide the second term by 6q, I get a 3. So tell me what is common on both terms, which means you're going to tell me what's in parentheses. So in parentheses, I've got an a plus 3. Then tell me what's left once you divide that out, and I get an a plus 6q. All right, so now we're going to go another step into factoring with another type of factoring, and these are trinomials. And when I factor a trinomial, and for this first entire set, actually for the rest of this video, my lead coefficient, or the big number in front, is going to be a 1. Okay, so I've got a shortcut for this, and then later on I'm going to kind of explain what we did. But this is a shortcut that I'm showing you. So what I'm going to do on the side is I'm going to make a list of factors for 35. So that gives me 1 and 35, and that gives me 5 and 7. So that's my list. From that list, I need to find 2 factors that will add up to my middle term, which is positive 12. So I'm going to find out that those 2 numbers are 5 and 7. So in order to factor this, we're going to take the square root of the first term, which is x squared. So his square root is x. And then I just found a positive 5 and a positive 7. So I've got a positive 5 and I've got a positive 7. And now you have successfully factored that. So I don't have time to do this for every problem, but you do. So I'm going to show you what would happen. You just turned in a trinomial into a factored form. So what would happen if we FOILed this? So take this first term times everything over here. I would have x squared plus 7x, and I'm done with this. And now take the second term times everything over here. So 5 times x is 5x, and 5 times 7 is 35. So when I've combined like terms, I end up with the exact same thing back. So you're finding what 2 binomials were multiplied together to give you what you started with. That's what you're finding. All right, so we're going to try another one. We have x squared minus 13x and plus 42. So again, first thing I do every time I factor, is there anything common across all 3 terms? No, there's not. So since this is a trinomial, I've got an x squared, an x, and a no x. I'm just going to take the last term, factors of 42. So that gives me 1 and 42, 2 and 21, 3 and 14, and 6 and 7. Okay, those are my factors of positive 42. So if it's positive 42, you know your signs have to match. They either have to both be positive or both be negative. On the last one, it was positive 35, and I had to add to a positive 12. So these were both positive. On this one, I'm trying to multiply to a positive 42, so my signs are the same, but add up to a negative 13. So both of my signs must be negative. So what adds up to negative 13? Well, this would give me, if they were both negative, that would give me negative 43. That's negative 23. That's negative 17. And there's my negative 13. So when I factor this, I've got x minus 6, x minus 7. Also remember that order does not matter when you're multiplying. So I could write this as x minus 7 times x minus 6, and it would be the same thing, because I would have this term, or I would have the yellow thing times the green thing. So I can flip-flop the order. So x minus 6 times x minus 7 is x minus 7 times x minus 6. So it doesn't matter which one we write first. All right, so let's try another one. We have p squared plus 18p minus 88. All right, so first thing I do every time I factor is see if there's something common. Do I see anything common? No, I don't. Those have p's. He doesn't. There's nothing common across all three. So what I'm going to do now is take factors of 88. Now notice that I'm going to multiply to a negative, which means one sign's going to have to be positive and one sign's going to have to be negative. And I'm going to show you a trick for that. All right, so I've got 1 and 88. I've got 2 and 44. I've got 4 and 11. Those are the three sets that will go to, actually that's a lie. There's a 22 in there. I can do 4, hang on, my brain just melted. All right, 4 and 22, and then I can do 8 and 11. I'm sorry, I was ahead of myself. All right, so 1 times 88, 2 times 44, 4 times 22, and 8 times 11, and those are the only factors that I can do. Now, since my factors have to be one positive, one negative, because I'm multiplying to a negative 88, then I'm going to look at the sign of the middle. Since the sign of the middle is positive, my bigger number must be positive. So I'm going to look at my list of smaller numbers, and these will all go negative. And now I can make my choice. So really what this just turned into is a subtraction problem, because negative 1 plus 88 is 87. Negative 2 plus 44 is 42. Negative 4 plus 22 is 18. There's your numbers. Okay? So what did I mean when I said a subtraction problem? 88 minus 1, 44 minus 2, 22 minus 4, 11 minus 8, which didn't work. So I've got two sets of parentheses. The square to the first goes in the first spot. And then what are my two numbers? One of them is a negative 4, and one of them is a positive 22. So let's try it again. I've got x squared minus x minus 20. So I need two numbers that will multiply to negative 20. So your signs are different. And remember that this is a negative 1 right there. So what are my factors of 20? 1 and 20, 2 and 10, 4 and 5. So which numbers will be negative? The larger numbers will be negative. So up here, the larger numbers stayed positive. Well, now the larger numbers will be negative. So this is a negative, negative, negative. Okay, so I'm looking for two numbers that multiply to negative 20. So 1 minus 20 is not negative 1, it's negative 19. 2 minus 10 is negative 8, doesn't work. 4 minus 5, there's your negative 1. So I've got two sets of parentheses, square root of the first goes in the first spot, and then I'm going to have a positive 4 and a negative 5. All right, r squared plus 2r plus 3. All right, so it's Halloween and I'm recording this. Okay, so I need two numbers. First of all, first thing I do every time I factor, is there anything common? They have r's, he doesn't. There's no numbers across all three, so there's nothing common. So I need factors of 3. Okay, so 1 and 3. And since it's positive 3, my signs have to be the same. If it's positive 3, my signs have to be the same. So I need two numbers that multiply to 3 that add up to 2. And unless I make that negative, which I cannot do, then I'm stuck. Okay, so this is called prime. So I'm going to pause for just, I'm not going to pause the video, but I'm going to pause live and talk to you about prime for just a second. So this, your answer to this is it's prime. Why? Because the only way to get this to be a 2 is for this to be negative, which means this would have to be negative. So two numbers that multiply to negative 3, I could have a 3 and a negative 1, but I need to keep my signs the same. So let's look at arithmetic for just a second. Do you agree that 13 is prime? Because its only factors are 1 and itself. So in this case, this is prime because its only factors are 1 and itself. Okay? Its only factors are 1 and itself. Okay, so I can break down 13 into 1 and 13, and that's its only factor, so it's prime. I can break down this trinomial into 1 times that, and so that's its only factor, so it's prime. Now, for future reference, I could break down to 13 into 2 and 13 halves, or I could do negative 1 and negative 13, or I could do 52 and 1/4. I could do all this kind of stuff. So remember that I can break it down, but if I do, it's going to go ugly. Okay, so for future reference, for where we're headed, I will eventually be able to break this down. It's just going to go ugly when I do. So for right now, we're just going to keep it basic, and we're going to say you're prime. Okay. All right, so let's try next one. I have y squared minus 5y squared minus 5y positive 6. Okay, so first thing I do every time I factor is see if there's something common. Can I pull something out of all three terms? No, I cannot. So I need factors of 6, positive 6. Your signs will be the same. What will your signs be? They will be negative because I need to add up to negative 5. So my options are 1 and 6 and 2 and 3. Since they need to add up to a negative 5, I'm going to go ahead and change all these to negative. So now these added together gives me negative 7. That's not what I'm looking for. These added together give me negative 5. That's what I need. So two sets of parentheses. One square root of the first goes in the first spot, and then I need a negative 2, and I need a negative 3. Okay? Eventually, we're going to finish this out by saying the last thing I do every time I factor is make sure I'm done, which means I'm going to look at each individual factor and see if I can break those down. But right now, we're just trying to get in the swing of factoring. So first thing I do every time I factor is see if there's something common. Is there something I can pull out of all three terms? No, there's not. So I need numbers that multiply to negative 30. So your signs will be different, and the sign of the bigger numbers will be negative. So I've got 1 and 30. I've got 2 and 15. I've got 3 and 10. And I got 5 and 6. My bigger numbers will take the sign of the middle term. Okay, so do I have any of those that when I do what the signs say, I get a negative 1? 1 minus 30 is negative 29. 2 minus 15 is negative 13. 3 minus 10 is negative 7. 5 minus 6 is negative 1. So two sets of parentheses, square root of the first in the first spot, and then I've got a positive 5 and a negative 6. All right, we are going to end up, this is video number 2 for practicing. We're going to end up with at least one more video. All right, so I have an 8x squared plus 48x minus 56. So the first thing I do every time I factor is see if there's something common. And there is. I can divide an 8 out of all three of those. So if I divide by 8, I now have 8 times that trinomial. So now I'm going to break this trinomial down, if possible. Okay, so you have factored. You just haven't factored completely yet. So I'm going to go ahead and pull this 8 down and do two sets of parentheses. If I can't factor this, then this will be my answer. But it's not prime. you have factored. We're just going to see if I can factor this one down some more. So I need two numbers that multiply to -7, so 1 and 7, but my signs are different, and the bigger number will take the sign of the middle term. So my question is, does this work? -1, +7 gives me +6. This works. So the square root of the first in the first spot, and then one gets a -1, one gets a +7. All right, let's do another one. I have a 3x to the third plus an 18x squared plus a 24x. So the first thing I do every time I factor is see if there's something common. I can pull a 3 out of everything. I can also pull an x out of everything. So I'm going to pull out a 3x. That leaves me with x squared plus 6x plus 8. And now I need to see if I can break this down. So 3x is going to come along for the ride. This is factored. I just need to see if I can keep going. So in anticipation of the fact that I may be able to keep going, I need two factors that multiply to 8. And it's +8, so your signs are the same. Your signs will be the middle term signs. So my signs will all be positive. And I notice that 2 and 4 give me that 6. So I'll have an x plus 2, x plus 6. Okay? And then our final example of this video is going to be a -6 m squared q minus 7mq plus 49q. Okay? So I would like to know what's the first thing I do every time I factor. I see if there's something common. I also want to pull out whatever it is. If there is something common, I'm going to pull out a negative. Okay, I am going to pull out a negative because I don't ever want to lead off negative. Okay, so I'm going to change the signs of my trinomial. So I do notice everything has a q. So I'm going to pull out a -q, and that's going to give me a 6m squared plus 7m minus 49. And now that's as far as I can go. Okay, I have factored, but I don't know how to handle this one yet. And I'm telling you right now it's not factorable. So this is as far as you can go. So it's not prime. You have factored it, but that's as far as I can go.